So we are going to start the third process of heat exchange, and that is your radiation. Right? This is the topic for today. Right? Radiation. So how many of you are aware of this? That what a radiation is? Yes. If I ask you about radiation, I mean, if I ask Meerab that what a radiation is, so what will be your answer?
Sir,
Hassan?
I know the
Oh,
definition,
sorry.
but
Okay, okay. Yes,
I don't know
yes.
how to so I don't know how to actually explain it.
Okay, simply, Hassan, what's your idea about radiation? What is a radiation or what a radiation is?
Sir,
Yes.
it's the travel of the energy through space or through a medium.
Okay. Any other easy approach, Ariba? What about you? What do you say?
I don't really know how to differentiate it either.
Okay, and Yahya?
It's like energy transferred
Okay,
without like the energy transferred as particles or like light, I guess.
okay.
Even
So
the
if I say that radiation is a process of energy transfer in the form of waves, so will you people agree or not? Or will you disagree?
uh, so like isn't like alpha radiation? That's not wave. That's new particle.
All the waves which are electromagnetic waves, they are called radiations. Okay?
Yes.
Yes, so light is also a form of radiation. But what we use over here, thermal radiation, they are something else. So we are going to have the idea about that. Okay, if I talk to you about the wave spectrum, right? Can anybody tell me what are the main bands or main type of waves in the electromagnetic spectrum? This is your electromagnetic spectrum. Okay, I
Radio.
can give you a hint. Sorry,
Gamma.
gamma rays, X rays,
X.
ultraviolet, violet,
Visible.
sorry, visible light, then
Infrared.
infrared,
Uh,
then
micro
microwave,
radio.
and radio wave. Okay, so actually, in this electromagnetic spectrum, they all are having different traits. We will talk about that in waves. This is visible light, this one, and these are your thermal radiations. We will talk about that. I mean, we will talk about this part of the electromagnetic spectrum.
Sir, can you repeat
They
what is
are
it?
you. I mean, when we talk about electromagnetic waves, there are seven types, right? How many types of the electromagnetic waves are? There are seven types of electromagnetic waves, and those electromagnetic waves are actually um considered
So,
as yes, yes.
what does IR stand for?
Oh, yes. IR stands for infrared radiations. IR stands for infrared. Actually, I will explain this in detail. When we say red, here invisible spectrum, which is the lowest level, it is red, and what is the highest? It is violet. Okay. So, Ariba, do you know that when we divide this visible line or visible light, how many colors do we obtain?
I think six, correct?
Six or seven?
Seven, all right.
Yes, seven. Hassan, seven होते हैं.
जी.
VIBGVIBGYOR. These are violet, indigo, blue, green, yellow, orange, and red. So all those waves which are having frequency less than red, they are called infrared. And all those which have frequency more than violet, they are called ultraviolet. What do we call them? Ultraviolet. Okay. Will you remember these all?
Sir, please repeat again.
मैं ये कह रहा हूँ कि when we talk about the frequency band, we have visible light is divided into 7 colors: V, I, B, G, Y, O, and R. This is violet, indigo, blue, green, yellow, orange, and red. And the frequency of violet is highest and frequency of red is lower. I mean, red is low frequency. Okay. And violet are high frequency light, high frequency. So those all waves which have lower frequency than red, they are called infrared. Infra mean low and red mean lower than red. And all those which are having higher frequency than violet, they are called ultraviolet. So ultra mean above and violet mean above violet. So their frequency is above violet, more than violet. Infra mean lower, and their frequency, the frequency of infrared is less than your violet frequency, red frequency. Now is it clear?
Yes, sir. Thank you.
Okay. So actually, we have to talk about this part of electromagnetic spectrum. So let's start our topic with proper information of radiation from your thermal concern. Radiation is the transfer of thermal energy by electromagnetic waves. The conduction and convection requires any medium to transfer the thermal energy. However, the radiation does not require any medium. It can take place in vacuum. Why? Because I told you that these all electromagnetic waves can travel in vacuum. Okay, they can travel in vacuum. That's why light is reaching to us from vacuum or through vacuum. X-rays are coming to us through vacuum, and so on. There are so many things which are coming to us through vacuum. So if I consider this all, I can believe this thing, or I believe this thing, that these infrared radiations are also coming. That's why we can feel heat. Nowadays, less infrared is reaching to us. That's why we are feeling cold. So let's have this diagram in front of you. So this is a heater. You are using wood to get energy. So yes. Now screen shared है अभी भी या गायब हो गई? Oh,
नहीं सर है.
ओके ओके ओके. लैपटॉप में कोई थोड़ा बहुत आज ग्लिच कर रहा है. तो देखो, the heat is reaching to this boy or this person through convection, because I told you that when the heat or air is heated up, it moves up. But this would not get heat through convection, because heat does not move straight due to convection. So this guy would have heat due to radiations, and this guy would have heat due to conduction. So they all are in front of you. So this is what we are talking about, that radiations are in the form of waves. So the source of thermal energy in radiation is the radiation that transmits energy in the form of waves, known as infrared radiation. So what is the other name of thermal radiation? Infrared radiation, right? When they are absorbed, the energy of the wave transform into thermal energy of the receiving body. I mean, I will make it simple. So when they are absorbed, temperature increases. What happens when they are being absorbed? Temperature increases. So radiation is the mean by which energy reaches from the sun. I mean that this is that form of uh, mode of heat transfer due to which energy is reaching to us from sun, right? And sun is the sun's energy travel to the earth as an electromagnetic wave at the speed of light. So this was all what I told to you generally, and this all has been written also on that. So what is the speed of light? uh yes, who will tell me? Hassan will tell.
पता नहीं सर.
Okay, yeah, yeah.
It's approximately 300,000 kilometers per second.
Yes, 300,000 kilometer, or you can say 300 million meters. 1 2 3 4 5 6 7 8 meters per second. This is the speed of light. Okay, remember this thing. This is what? This is speed of light. And who will tell me what is speed of light? Speed of sound? Ariba. Yes, Ariba. Yeah,
The speed of sound, I don't exactly remember it, but it was something like 343 meters per
yes,
second.
exactly. 330 to 340 meters per second. Perfect. You're right. So, can you, Mirab, can you tell me how many times the light or heat is faster than sound?
What, sir?
How many times or by what factor speed of light and heat is more than speed of sound?
I don't know.
Okay. Can you deduce from this slide? I have written somewhere.
Uh, like almost a million. Maybe.
Yes. Because if I consider this 300 and this on average 300, then it is almost 1 million. ये कितना बनेगा? 10 power 6. Yeah, this is 1 million ना? ठीक है? So remember one thing, that speed of light and radiations. I'm talking about radiations, right? Heat is almost 10 power 6 times speed of sound. So that's why remember this thing, that when heat is reaching to you from a hot body, from a source in the form of radiation, its speed is so fast. Remember this thing. It's not that the heat takes some time to reach to you. No, it's immediately, right? So describe how to distinguish between the good and bad emitters are absorbers of infrared radiation. So, is this all profile picture clear to all of you? That how what the radiations are? Now, I'm actually trying to explain you further mm, properties of the radiations. For example, we have to discuss emission of radiation. Emission of radiation means how the radiations are being radiated. You know, every one of us is radiating infrared. Do you believe this thing? Hmm?
We have thermal energy then, yes.
Yes, we all radiate IR. But okay. One more thing. Who amongst you is fond of National Geographic channels or Animal Planets?
What?
Yeah, you.
What? Didn't understand.
There was a TV channel which was National Geographic. Yeah, National Geographic or
Yeah,
Animal Planets
I used to.
or Discovery.
Yeah, Discovery.
Yes, there were three channels. Ariba, did you ever watch these three or any one of these channels?
I've had to watch National Geographic for essays before, but never out of
Yes.
sheer interest.
Okay. If I ask you that when these uh, when those people who are basically there who are going to research over there, when they take videos or when they make pictures of the animals at night, how do they figure them out? Did you ever see their
Thermal
IR
camera.
videos?
Yeah, they
Yes,
are
they
thermal
use thermal imaging cameras. Exactly. Thermal imaging cameras. So please,
camera. It's not
you
just
people are genius people. Yeah, really. I appreciate your observations. So thermal imaging cameras are used to imagine or to trace out their thermal radiations, and they are seen black and white in that. Is it?
yeah, usually.
Yeah. Usually they seems black and white. So those part of the body which are imaging radiations or which are emitting radiations, their color is different. Mostly they are black, and those which are not emitting radiations, they appear white. So that is, we all emitting radiations, but radiation emission depends upon some factors. So hotter the object, it would radiate more energy. Right? So the temperature of the tube with the dull black surface is found to be decreased more rapidly than that of the shiny tube. Why is it so? Because remember this thing. I would like to write some of the points over there, that black and dull surfaces are best emitters and absorbers of radiations. Emitters and absorbers of radiation. Okay, absorbers of radiation. So when we say that they are very good absorbers and emitter of radiation, so what do you think? What do you think? What will be, for example, both of these tubes are placed at uh, suppose 50 degrees centigrade. Okay, both of these tubes are placed at 50 degrees centigrade. So which tube will emit more radiations? This will emit more radiations. Okay, and when it will emit more radiations, it would be cooled down. Basically its energy would be decreased, so its temperature would fall rapidly. Remember this thing, there is a rapid change in temperature for this one. But in this one, because it radiates very less, it is good reflector. Shiny surfaces are very good reflector. I will tell you a lot of examples ahead. So remember this thing, that there it would have a small change in temperature, right? It will have a small change in temperature. So those bodies which are having black colors, they are very good emitters. That's why this do you realize recognize what is that?
The back of a fridge.
Yes, back of the fridge. Very good. Or back of the dispenser, or back of the refrigerator. Or here we use black color. Why? Because when the heat, when the gas is moving through these, Ariba, they they are really hot enough. These plates or these pipes. So why do we make it black? Because it will radiate a lot of energy. So when will it radiate, its temperature will become less, or its temperature will be decreased a lot. That's why we use black colors over here. Now this is one of the examples in front of you. Example of poor emitters. We don't want these athletes after marathon that they radiate the energy, because they have lost most of their energy in the body. So at the end of the race, the marathon runners wrap themselves in blanket to prevent them from cooling down too quickly. So forget about this. Why do we use the silvery shining bottle to keep the hot water inside it? Do we do that or not? We have some bottles which are silvery polished from inside. Thermos जिसको कहते हैं. This is thermos flask. Why do we use thermos flask, Ariba?
To maintain the heat of the liquid inside.
Yes, to keep the temperature of the inner hot body, hot water, uh, or to keep them, or to maintain the cold temperature of the body. So actually, what do? We make its inner surface shiny, right? When we make its inner surface shiny, the radiations are not being released out. They are reflected back. They are trapped inside, right? Due to that, the heat is contained by this bottle. That's why thermos flasks are made up of shiny silvery polished bottle, right? So there are so many example of that. A body is temperature. Yes, check this one out. It is a polished surface and there is a dull black surface. A wax is attached, and then after that these two plates are placed in front of, sorry, at an equal distance from a burning source, right? This cork is held by wax because wax is not yet melted, but this falls down because wax start melting because it absorbed a lot of radiation. That is the reason we used to wear dull colors in winter, right? The body temperature rises when absorbed radiation, and radiation absorbs that observation shows that the wax on the back end of the metal in a short time, and the raw cork on that falls off. The shiny lid remains fairly cool, and the wax on the waxes remain unmelted. You know why we select silvery polished or white color vehicles usually in hot areas? Because they reflect the sunlight. They do not get heated rapidly or so quickly in sunshine, because we have to travel in the in sunshine. धूप में हमें चलना पड़ता है. So you know, if that would be black, black colors would absorb a lot of radiation, and its efficiency for AC will be decreased. Remember this thing. So it's really a great mechanism of radiation. So I'm here because those all were examples in from your daily life, but I want to make my topic wind up. The rate of energy transfer by radiation is affected by surface temperature, color and texture of the surface, and surface area. So these are three factors which affect the radiation. So remember this thing. What are three factors which affect the radiation? Surface temperature, surface color, and surface area. Right? Now check this one out. This is the color and texture of the surfaces. Right? There is an arrow which shows that dull black surfaces are very good emitters and absorbers, right? But they are poor reflectors. Then we made them shiny, a little bit shiny black. It is not good absorber and emitter than black, but better than white. And then the silvery shiny polished is polished surfaces are the poor emitters, but they are very good reflectors but poor absorbers. Will you be able to remember this texture diagram?
Sir, what is the difference between emitters and reflectors?
Yeah, emitters are basically which are going to release the radiation, right? And reflectors means if radiations are there, they keep them inside. They do not let them out. Okay? They retain the radiations inside. Or if radiations are coming from the outer side, they do not let them to get in. They reflect them out.
मतलब
These are
emitters
the
Once they
Huh,
absorb and then
emitters,
they emit.
yeah, yes, once they absorb, then they emit. Got it?
Yes, sir.
Okay. Then, yeah, these are some example questions. I would like to come to this question. Yes. A bread can be cooked. This is a past paper exam. Bread can be cooked by placing it below, but not touching a heating element. But not touching the heating element. Yeah. Do you see this diagram? Okay. Which process transfers thermal energy from the heating element to the bread? So convection से तो नहीं हो सकता because convection will send cold air down and conduction हो नहीं सकती because air is inside and only procedure is radiation.
Radiation.
What is the only procedure? Radiations, right? Then this is one of the past favorite question that the diagram shows a thin copper plate that is very hot. Side is black, one side is black, one side. So left hand will definitely get more energy than right one. Okay, because of radiations, because black body is very good emitter of radiations. Got it? So I think it's very easy to understand. I would like to have, yeah, this is another past paper question. The diagram shows four cans of in the cool room. They are painted as shown. One pair is lifted with sorry, filled with hot water and left to cool down. The other pair is filled with cold water and placed near the infrared. Okay, these are the infrared. So the hot water in the black can cools more quickly than hot water in the white can. Number one observation. The cold water in the black water heats up more quickly than the cold water in the white can. Which row shows the reasons? Because better emitters of infrared radiations are black colors, and better emission of better absorbers of infrared radiations are black colors. So black colors are very good reflectors and sorry, very good emitters and absorbers of radiation. You have to remember this thing, right? So yes, this was what when we talk about all the aspects together. Conduction. This is basically the topic name is conduction, convection, radiation. Conduction, convection, and radiation. Okay, is it? So conduction, convection, and radiation. Okay, I shown you three factors basically, and out of those three factors, we explained one till now. What about the surface temperature? That we have explained already in the start of the lesson. And what about the surface area? How will you relate that? Radiation rate is directly proportional to surface area. Wider the surface area, more will be the temperature or more will be the radiations, either emission or absorption, but it would be more. So remember this thing, that this all is very important to know that why do we have big heaters or reflection surface of the heater very big, because they are very good emitters and absorbers, because surface area radiation rate depends upon the surface area. So you have to keep all these points in your mind from radiation. Then we have studied conduction and convection. Okay, अब आइए इसमें heat transfer at home. So how do we control heat transfer at home? Radiations are from the roof, convection is from the walls and so on, then conduction is from the wall, radiation is from the body, and then conduction and convection, they all are taking place all around. Similarly, then we have some sort of geyser, convection current driven hot water from the top of the boiler into the hot water storage tank, right? Check this one out. If you consider this is a normal daily life geyser or hot water reservoir. So what is happening? You have heating of the water over here. So hot water is driven upward like this, okay, and from here it comes out, and cold water remains down. Okay, cold water आपके पास क्या है? Basically the water which is cold it comes from the reservoir. Sorry, I have to draw this red with red. जब आपका गीजर काम कर रहा होता है ना, तो what is happening? The cold water is coming from the tank. This is the tank, storage tank, and then it comes down, then here and here. Okay, but here the water gets heated. ये आपके heater geyser का heater है, and then it moves up and up and up, and from here it it can be basically for overflow. We have this area, and normally we collect the hot water from this tap. ठीक है, and the water which is left behind, we can use that over here. So both can be considered as the geyser outputs. ठीक है, so cold water from the storage tank is drawn to the boiler to turn, in turn it becomes heated. So this is the geyser application. Houses in hot countries are often painted in white to keep them cool. Factory roofs are sometimes coated with aluminum paint. This reduces the absorption of radiation during the day and cuts down the emission of radiation during night. Okay, so these all are basically daily life applications of your radiation. This was that what I was talking about. Vacuum flask. Vacuum flask is one of the application that keeps the drinks hot or cold both for hours. It has these features for reducing the rate which thermal energy flows out or in. So there are three main aspects of that. One is stopper, second is the gap with air removed. Air is removed, mean vacuum is produced there, and then glass or steel wall, silvery polished, and then silver polished surface is there. Okay, now check what are the function of all these. Can you tell me why do we have silvery polished surface, inner and outer? I'm starting from third one. How does it reduce the thermal energy transfer, and which type of thermal energy transfer is reduced by this feature? Third one.
Uh, it reflects infrared, so
Yes, so radiations are controlled by this. So why do we use glass wall?
which
Yes, to avoid conduction, right? Why do we keep gaps, removing air to avoid convection? If there would be air, it would convect. So we avoid convection over here. अरीबा बेटा बात समझ आ रही है?
Yes, sir.
And why do we use the stopper? To avoid convection and basically evaporation. So there are so many features built in one vacuum flask. Okay, so an insulated stopper is to reduce conduction and convection. This is the function of one. The double walled container with gap between the walls, air has been removed from the gap to reduce the conduction and convection. Wall with silvery surface are to reduce the radiation. So these are three main features which have been induced over there. So this is asked to you. So please be careful about this. Mirab, is it clear, beta? Hassan and Yaya, is it also clear
Yes.
to you all of you?
yes,
Yes, sir.
Okay, now let's talk about refrigerator. ठीक है, ये भी आपका एक पास पेपर का क्वेश्चन है. So in a refrigerator, cooling unit is at the top because refrigerator is made in such a way that cooling is at the top, and then rest they all are less cool and less cool. The cooling unit is of the refrigerator. So why the cooling unit is placed at the top? So cold air falls and warm air is displaced upwards. Cold air is bad conductor, so heat cannot be conducted into that. Cold air is a good conductor, so heat is conducted out of the refrigerator and cold air stops at the top, and so it prevents the convection. So according to your knowledge, which option should be correct?
A.
A. Why? Because when cold air is there, it sinks down. So cold air sinks down and hot air moves up. So when you place a hot object inside, what happens to that? It makes the air surrounding air hot, and that hot air moves upward, and remaining cold air it would sink down. Right? So is it clear?
Yes.
Okay, there is a vacuum between the double walls of the vacuum. Let's just discuss this one. So should I, I mean, ignore it, or should I move forward? We have just discussed this one. Are we telling?
Yes, sir.
You can see that option. So why you that? There is a vacuum between the flask and the vacuum flask. Which type of the heat transfer are reduced by the vacuum? Vacuum is provided to avoid conduction and convection, because radiation is not being stopped over there, radiation is not being stopped there. So those options in which radiation is used or radiation is written, you will not opt them. Okay, so that's all about this conduction, convection, and radiation. These all are MCQs, and I want to go to the theory questions basically, so that we can have a good comprehension of the topic. So if you people allow me, I would switch the topic to the theory. Let me stop the streaming, and then I will be back with practice questions.